Okay, 7.4 is called separation of variables and review exponential functions. So basically in this chapter, in 7.1, you learn how to integrate trig functions, you learn how to integrate polynomials, inverse trig functions, logs and natural logs. You learn how to integrate all of that. You also learned in 7.2 how to do the chain rule backwards. So basically in this chapter, you're learning how to integrate every possible function in calculus. In algebra calculus, same thing. The last section called 7.4 is we haven't learned how to do implicit differentiation backwards. And that's what we're going to learn today. So in order to do implicit differentiation, you need to do separation of variables, and we also have to review natural log functions. So let's just go over some rules. If you have an e right here, there's also a e right here. It's automatically a 3. The natural log of e is equal to 1. Again, if you have an e here and an e here, this little negative sign can come up here, so 2 to the negative 1 is 1/2. So those are some quick little rules. The next rule is you can take this and put it into exponential form. So e raised to the 1.609 is equal to 5. Or you can write it in log form. The natural log of base e of 54.6 is equal to 4. Usually don't see the e in the problem. Okay, some more equations. If you want to solve for x, it's in natural log form and there's a little imaginary e there, so I'm just going to do the loop around. E to the first is equal to x plus 1, so e minus 1 is equal to x, solving for x. You need to know how to use your natural log functions, that's why we're reviewing this. And the first thing I'm going to do is divide both sides by 2, so e raised to the 3x is equal to 3. Natural log of 3 is equal to 3x, and I can check it because there's a little e down there, the loop around. So the natural log of 3 divided by 3 is equal to x. And they might even go a little step farther. This is the same thing as 1/3 natural log of 3, which is the same thing as the natural log of 3 to the 1/3, which is the same thing as the natural log of the cube root of 3. So they might even go a little bit farther. So simplify natural logs. If there's an addition sign in between, you multiply the 6 and the 4. Here I'm going to put the natural logs together on the same side. So all I did was subtract the natural log of 3. There's a minus sign, so I can rewrite it, but I got to put a division sign in between. E to the second equals x over 3. I just put it in the loop around. So 3e to the second is equal to x. So these are all the quick little rules that you would have learned in algebra. I guess I just did a few more. If you want to get y alone, it's e raised to the 3x plus 7 equals y minus 2. So e raised to the 3x plus 7 plus 2 is equal to y. Bring these over together on the same side. It's the natural log of 2y is equal to 4x because adding means to multiply. E raised to the 4x equals 2y. So e raised to the 4x divided by 2 is equal to y. So this page is just a quick, the first page was the rules and the second page was just another reminder. This is the same thing as e to the second times e to the negative natural log of 3. You could write it like this, or you can write it like this. And then this is the same thing as e to the second times e to the natural log of 3 to the negative 1, which is the same thing as e to the second times e to the natural log of 1/3. Same thing with this, you can split this up and put a multiplication sign. Bases are the same, you would have added your exponents. This would have been e to the 2x, and there's a little e here, so the rule says you can cancel this out, so there's a 4 in front. So these are all just quick little rules from natural logs. Okay, this is on the test, but I did not find this in the book, so I just want you're gonna see one of these on the review sheet, so you need to know how to do this. This kind of brings back physics and calculus. So this is a resistance proportional to velocity problem. A resistance encountered by a moving object, such as a car coasting to a stop, to an object's velocity, or a skater or whatever, but this is the physics formula. V is equal to the initial velocity is V sub 0, e raised to the negative k divided by mt, and the m is the mass, and the k is the rate, and the t is the time. So this is the mass, and this is the k, and how long to coast from 7 meters per second to 1 meters per second. This is not calculus. They just want you to know it starts off the velocity at 7 meters per second, and you want to coast down to 1 meters per second. So the 1 is going to go on the left side, and the 7 goes on the right side. E raised to the negative k is 2.5 divided by 50 to the t. We're trying to find out how long, or we're trying to figure out what the time is. So I'm going to divide both sides by 1/7 e raised to the negative 2.5 divided by 50t. If I want to get e alone, I'm going to come over here and natural log both sides. As long as you natural log both sides, you're good. The natural log of 1/7 equals, I can take that whole thing and put it out in front. And you know that the natural log of e is 1. So in order to get t alone, I just have to take the natural log of 1/7 on my calculator and divide by the negative 2.5 divided by 50. And you should get the time of 38.918 seconds. I always go out in calculus to 3 decimal places. So this is not calculus, but the next part, how far is total distance? And when you hear the word total distance, you know you need to integrate. So we need to integrate the original, the 7e to the negative 0.05t dt. I got negative 0.05. The negative 0.05 is the same thing as a negative 2.5 divided by 50. I just simplified it. So, okay, I'm going to take the 7 and put it out in front. And then I'm going to use u substitution from 7.2. I'm going to let u equal a negative 0.5t. I'm going to let du, find the derivative of that. So du divided by negative 0.05 is equal to dt. And then I'm going to go over here, and I'm going to leave the 7. I'm going to leave the e. I'm going to replace the negative 0.05t with the u. And I'm going to replace the dt with du over a negative 0.05. So that can come out with that now. So how do you integrate eu du? It's just eu, so it's 7 divided by a negative 0.05 e to the u plus c. And if it's coming to a complete stop, then it needs to be 0, 0. It doesn't say that, but you need to know that if it comes to a complete stop. So this is 0, and this is 0. E to the 0 is 1, so it's going to be 7 divided by a negative 0.5 plus c equals 0. So c is equal to 140 meters. Okay, now comes the last part, implicit differentiation backwards. So I'm just gonna bring back how to find the derivative first, and then we're gonna work backwards. So let's find the derivative like we did in chapter 4. The derivative of y squared is 2y dy dx, if you remember this from chapter 4. The derivative of a negative x squared is a negative 2x, and the 25 is no longer there. So now you're trying to solve for dy dx. That's a negative 2x over 2y, which ends up being a negative x divided by y. So basically what we're going to do is, they're giving you the derivative, they're going to give you this, and you have to go backwards to this. It's called separation of variables. Here it is. This is pretty much what we did, and here is the point. You need to put the x on one side and the y on the other, and that's why it's called separating the variables, because you're putting the x on one side and the y on the other. So let's do that first. So let's write that down. The y is usually on the left side, so I'm going to multiply, or just I can cross multiply 2, and that does the same thing. Do you see why it's called separating the variables? The title of this is Separation of Variables, because what I did was I brought the y's on the left side and the x's on the other side. And once you separate the variables, you need to integrate both sides of your problem. This is y squared over 2 equals a negative x squared over 2. And you only need 1 plus c. You don't need a c on both sides, because the c is just a number. And now, they told you the point that it's going through, so we're going to find the c. It's going through 3, 4. So y is 16 divided by 2 equals, I put that in the wrong spot, sorry, it's 4, 3, not 3, 4. It's 9 halves equals a negative 16 halves plus c, which is the same thing as 9 halves plus 16 halves equals c, which is equal to 25 halves. So I'm going to go up here, and I'm going to replace the c with 25 halves. So you're going to y squared over 2 equals a negative x squared over 2 plus 25 over 2. And I can multiply everything by 2, and I get y to the second equals a negative x squared plus 25. And if you look back at your problem, it's identical to what we did. So, okay, let's do another one. We'll do 3 more, I think. And I think that's all for separating the variables. We're going to use this later. We're going to separate the variables. I'm going to bring the y over to this side, so I have to divide by y, and I'm going to multiply by x. Again, the y is always on the left side and the x is on the right, and you can put the 2 on either side, it doesn't matter, I just put it on the x side. After you separate your variables, you integrate. This is the same thing as y to the negative 1 dy equals 2x dx. If you add 1, it's the natural log of the absolute value of y equals x squared plus c. You are going to plug in 0, 3 at the spot. Natural log of the absolute value of 3 equals c, so that's what it equals. I'm going to use my natural log ability and bring these over to the same side. If I'm subtracting, it's really the natural log of y divided by 3 equals x squared. E to the x squared is equal to y divided by 3. So 3e to the x squared is equal to y. As you can see, that natural logs play a big part in separating the variables. Another one, I'm going to bring the y over to this side, and I'm going to leave the 3 over on that side next to the x. This is the same thing as dy, y to the negative 1 equals a negative 3 dx. As you can see, I separated the y's and the x's. I integrate. This is the natural log of the absolute value of y equals a negative 3x plus c. I can incorporate the 0 and the 2. I'm going a little faster because this is the third problem. The natural log of the absolute value of 2 equals c. So the natural log of the absolute value of y equals a negative 3x plus the natural log of 2. I bring the natural log of y and the natural log of 2 together. Very similar to the last problem. This is the natural log of y divided by 2 equals 3x. E raised to the 3x equals y divided by 2. 2e to the 3x equals y. And the last problem, and we are pretty much done. So, the first thing you have to do, this is one that I saw in the AP test, you have to separate these. This and this are exactly the same in math because your bases are the same. You can add your exponents. I am going to bring this and join it with the y. So I'm going to divide both sides by e to the negative y. And this is the same thing. They're pretty much the same thing on both sides. I separated the y's and the x's. And this is e to the y equals e to the x plus c. And the point that they gave us was 0, 2. E to the second equals e to the 0 plus c. E to the second equals 1 plus c. So c equals e to the second minus 1. I'm going to go back up into here and put e to the y equals e to the x plus e to the second minus 1. This is the natural log of the absolute value of e to the x plus e to the second minus 1 equals y. There's a little e, and if I did the loop around, it would have gotten to this. Final answer. So, this was one of the problems on the AP test. You would get 1 point. You would get 1 point on the AP test if you could separate the x's and the y's. You're going to get 2 points if you can integrate the x's and the y's. You're going to get 1 point if you can find the c. You're going to get 1 point if you can get it to here, and then you get another 1 point if you can get it to there. So this problem is worth 6 points on the AP test if you can do all the steps for them. Okay, that's all the notes for 7.4.